Okay, let's go, guys. Just after you got comfortable, you come straight up now. No, anywhere you go. Kelly, Stefan, come and join us. I've been told we're on the clock, so don't get too comfortable there, Stefan. Kelly, if you want to choose your seat. You are here. Come grab a seat, Ralph. Okay, let's get started. Good afternoon, ladies and gents. Happy Saturday, happy COP Saturday. Thank you for choosing to spend your afternoon with us. I'm sure you're not here just to show support for the spokespeople up here, but you're genuinely interested in the topic, as we all are. This session is on solving water scarcity with rainfall, a climate-responsive discussion hosted by the UAE Rain Enhancement Programme, which has become somewhat of a bellwether, pun absolutely intended, of the innovative response to climate change, and especially when it comes to water scarcity. In this session, we're going to look at the scientific advances, the environmental considerations, the ethical dimensions, the climate responsiveness, and the policy and governance behind the topic of rainfall enhancement. So hopefully foster a deeper understanding of cloud seeding and its role in climate mitigation strategies. So we've only got 30 minutes to cover it all, so we'll get stuck straight in. Joining us today is Rolf Berger. There you are. WMO weather modification expert, Kelly Wanzer. Got that right? Yes. Kelly is the founder and executive director of Silver Lining from Washington, D.C. We have Stefan Erlenbroek, director of hydrology at the WMO. And we have Dr. Mohammed Mahmoud, director of the Climate and Water Program at the Middle East Institute. We're going to start with an opener for everyone. Stefan, we'll start with you as you're the furthest away. Tell us, where are we at on this journey of cloud seeding, and what are the main barriers to progress?
Yeah, thank you. Good afternoon. Happy Saturday. Happy COP Saturday. Where are we? I think at the one hand, we just had earlier, 2-3 hours earlier, some of the speakers, the panelists were actually speakers. We had a great review. It was a masterclass. Where are we with cloud seeding experiments? And I'm a hydrologist, so I'm not necessarily an atmospheric physics expert. I'm not at all, to be honest. But I think I do understand when it comes to the science. There's still a lot that we need to understand about the role of different agents and which concentration, when and how, how to form ice crystals in the most effective way. How can we generate efficiently enough crystals and then droplets to actually facilitate the precipitation process? I think that there's a lot of science to do, but some of my colleagues here will speak about it. Do we do several rounds in the interview, or
we got 4
rounds? So I don't to shoot all my.
Don't show all your cards at once.
Beginning.
No, wait for them to show theirs too.
But I think there we have quite a number of uncertainties. What happens after the rain is falling, after the rain is hitting the ground, and I think that is one of the main challenges, to fully understand the consequences, how to work with it, and I'm happy to expand in the next round and further
excellent.
on that. Thank you.
Kelly, from your perspective, obviously coming from the US, where are we at from where you see things on this cloud seeding journey in terms of the science and the research? Transparency is a big issue, governance?
My organization, Silver Lining, focuses on near-term climate risk. I'm not a scientist, and we're not directly engaged on cloud seeding. However, we're very much involved in the adjacent science of the effects of aerosols on clouds and the local systems around them, and then also, how we can do a better job of predicting the effects of what these applications will do. In the United States, there are 8 states with active cloud seeding programs, but there are very few science programs to directly study what these things are doing. At the same time, we're kind of in front of a disruptive moment in some of the science around us, where AI and machine learning and more data are likely to come online that make it more efficient for us to project what these complex cloud systems and local ecosystems are going to do. And that's going to become important, because as people wake up to the fact that these applications are there, that people are doing cloud seeding, they're getting more curious about what the ancillary effects of this are. And as the programs scale up, what does this mean for the systems around them? And that, of course, takes you to the governance and ethics questions of, do we understand this very well in terms of, both the benefits but any ancillary risks to others as these programs scale. So I think those things are likely to elevate as we learn more. And so hopefully people will see the benefits, and we'll also have better science around how these things play out.
So stay with me for a second. You say this raises the question of do we know this field well from an ethics and government perspective? Do we?
We do not. And I would say, most of the regulations and the international agreements around this area are very old, and had to do, in the days when people thought you might be able to aim these things as weapons. And not really the days when we're really trying to look at practical adaptive applications and where people really need these things. So no, there's really, there are some big gaps in the regulation and the international agreements around them. And as these programs grow, I think those are going to be significant areas to fill, and we're going to need science to fill them, really. So, and again, it's one of the reasons we're fans of the UAE program and the escalation of really good, strong basic science around some of the processes underlying these things.
We'll come back to how we bridge that gap in a second, because I think that's an important jumping off point. Roloff, your presentation this morning on a similar topic that we were fortunate to watch, you took a very academic approach to this topic of rain enhancement and climate mitigation strategies to tackle water scarcity. Where are we in terms of this response maybe from an academic perspective and having that body of knowledge that we need to use this to respond properly?
So I would say the first thing is we are a little bit frustrated. I mentioned the fact that so much effort and work has gone into this field, and you almost hope for more. It seems like every study, we just uncover more questions. And I think that speaks to the complexity of the problem we're trying to address. And that might detract some because we're studying a really, really difficult problem. But then every now and then you get a little study that shows you a unique view on things. One example might be the Washington winter seeding project, where using the latest technology, they were able to show this is the seeding effect observed in real time. There you can see this is what we do, and this is a response in the cloud. That gives you that hope, right? We can come to a better understanding of this very intricate link, and maybe that understanding can also make its way into better understanding the climate problem. And there I'm thinking of some of the projects that have been funded through the UAE REP that's specifically looking at how accurately do we model the aerosol cloud interactions in clouds. And this is the kind of things that gives us hope and gives us meaning in trying to put more effort into solving this complex problem.
Excellent, thank you. Dr. Mohammed, having heard the three openers there, and having had a discussion with you this morning on what's required from a policy standpoint, let me ask you this question. Is cloud seeding a good thing for the climate?
I think so. I think of it, and again, not to pick on some of the things I said earlier today, but sometimes cloud seeding gets a bad rap, not necessarily, when you really think about it, not because of the processes themselves. I mean, there's a lot of steps that occur from the seeding activity up until the point where you're potentially deriving a water resource from it, right? And there are things that are outside the control of those that are, putting in application, the programs to make it work, right? So atmospheric conditions, variables. I mean, the science at this point is known, how the processes work, how it would manifest, but there's a lot of other variables and conditions that are outside the control of those that are implementing the program. And then what happens? Activity, release of the material, activity in the cloud, precipitation, routing, infiltration. I mean, there's hydrologic processes involved, there's atmospheric processes involved. So sometimes people may look at it and say, oh, this is not as effective. Then there's the other question of, is it harmful to the climate or not? There's studies that can be done to illustrate it isn't. And again, it depends on what type of application. I'd mentioned this earlier. So I think where people get stuck is looking at the end point, not realizing there are multiple steps beyond the initial activity of seeding to get you to a point where you say, you know what, we have now derived this water source or water supply from this activity, because so many other things can happen in between that those that have implemented the project, that have actually done the seeding activity, have no control over. And a lot of it is Mother Nature. And so, in a way, climate is imprinting itself on the process.
Okay, so is that, I know asking scientists to speculate on something is a terrible idea, but I'm going to do it anyway. Is the science that we currently have saying that it is beneficial to the climate, because at the moment it's localized? There's obviously the idea that if this is a genuine breakthrough solution, it needs to be scaled and be across borders, across continents potentially. What are we looking at with that scenario, with what cloud seeding could potentially do to the climate?
I mean, it can, but I still think even when you scale it up, there's still limitations as far as being able to sort of attribute the raindrop to the process, right? I mean, there's certain things that are still, my colleagues may disagree with me or agree with me, but there's certain processes that I think there's limitations where you could say, you know what, we put this much material, if we're doing rain enhancement, salt into the atmosphere, we've condensed, we've had all this rain happen. It's still very difficult to attribute with definitive way that this came from this activity. Now, we can generally say that, yes, there is some enhancement, ergo some of it must come from this activity. But so even when the questions and the issues remain similar, or the queries, I should say, remain similar at the small scale as if it would be on the large scale. So it wouldn't necessarily resolve. Now, if you're able to boost the overall precipitation, that's a good thing, right? Using material and processes that have been studied and analyzed and known to not have harmful effects to the atmosphere. General lay audience may disagree, but scientists, know better, and maybe that's my bias. But I don't think that necessarily, removes some of the doubt or some of the questions, even when you scale it up. But you could potentially increase the benefit in terms of water potentially added.
Kelly, one of the things Dr. Mohammed said in his opening there was that cloud seeding tends to get a bad rep. You mentioned as well that there is work that needs to be done in what this technology is doing and why it's doing it. There's an issue of communication in getting the information and the science across to a broader audience. What's the approach there? How do you build that knowledge in a general public that may be skeptical of what this actually entails?
Well, it's a really interesting question because we see it in other areas, because we also work with scientists who are looking at using aerosols to brighten clouds and change weather and climate in a different way. And one of the things that we've done is to talk about people have a low awareness of what's already happening, and how many aerosols are already being put into the atmosphere inadvertently by aircraft, ships, and other sources of pollution. And so we start out by educating people that humans are putting lots of aerosols into the atmosphere for lots of reasons, many of them not accidental and unhelpful. And we have an opportunity in scientific ways to do these things in a more controlled and more constructive manner. That's been very helpful to us when we talk to the US Congress. So we've gotten actually bipartisan support for science related to these topics across the political spectrum, talking about it in this way, reminding people that we have lots of stuff going into the atmosphere that we don't understand very well. And now we're trying to do things in ways that are helpful to people. Most people in the United States don't know that there are cloud seeding programs in the United States. And then we talk about, they're trying to increase snowpack, they're trying to increase, water capacity, and there's pretty good, like, common sense support if you talk about it in those kind of ways. But of course, there's, lots of people who want to talk about it in a more sort of science fiction, sensationalized way. And we did have, in the past 24 months, I think, a cloud seeding program in New Mexico shut down by, an activist group and media raising concerns, and it was a long-standing program. So it's definitely not a solved problem, but we have seen, like, successful ways to help communicate. And I always say to people, like, if we're successful, it's become boring. We've talked about a lot of science, and people are like, oh, okay, I guess that's, something that people do. But right now, it's still at a quite a tenuous spot. Because it has a sensational aspect, and it has been thwarted, at least in one case recently.
And obviously very well documented in Disney's Cloudy with a Chance of Meatballs, which is obviously based on scientific fact.
That's right.
Yeah. So you've got that perception to overcome as well. I like the fact that you laughed at that joke, even though we both shared it this morning as well. So thank you for the support. Roelof, I want to come to you on this as well, because I think it's a pertinent topic for something that is perhaps considered a niche expertise in weather modification. How do you break down the science of what you're doing to get people to understand exactly what it is and why you're doing it? Same question, what it is and why we're doing it.
Sure. I have to start by adding, it was said in the morning session, it might have been Mohammed, that I think another component is openness and transparency in these programs. And that is it's much easier to communicate with somebody if there's not already a resistance and a suspicion that you're not being open with me. In South Africa, we had these kind of experiments, but it stopped around 2000. And to this day, I get people approaching me and coming to me and say the government's doing this and doing that with suspicion. And if you tell them there's nothing happening, they don't believe you. So I think the first step is really to be open about everything you do. We talked about data sharing. And then the second step is including the communities, including civil society in your plans. From the get-go, make sure you get public consultation going. And then the communication, I think, is embedded in that process.
Stefan, you were nodding your head vigorously when Roelof said about transparency.
No, yeah, thank you. I fully agree. Communication is absolutely critical, particularly if you want to achieve public acceptance of a new methodology. So you cannot fool people. And so it's really being very transparent with data is absolutely critical. If I may, I think your question to Mohammed was good. Is it a good or a bad thing, cloud seeding? And as a hydrologist, I would like to add it depends. That's what scientists always say. Oh, it depends, and it really does. Because I think even if we are able to do rainfall enhancement, this is fantastic. There's still a lot of science to do, and all the excellent work by Dr. Ayla and her team. It's really fascinating. However, the total amount of water which we have in the atmosphere is not defined by the local circumstances. Usually, it's transported to atmospheric circulation from another part. And the total amount of water in that, or moisture in that column or in that package of atmosphere is the same. If you make it raining out here, it means it rains out more here, but it's not somewhere else. So maybe the somewhere else is a different ecosystem, but it would require that rainfall input to optimize its ecosystem services, because it has been adapted to that amount of rainfall over decades, sometimes over centuries or even longer. So we do influence the ecological the input to ecosystems, which has consequences which we often don't understand well. The next point, I think the two of you have just making, maybe it's not only the ecosystem and what depends on the ecosystem, other ecosystems or people. Maybe other people live there, maybe it's a different country. And if we start at bigger scale to be able to really kind of manage rainfall. You know, I think we are not there yet, and I wonder if we ever will be. But we have to think it through in terms of what does that mean from a hydrological point of view? What does it mean for soil moisture availability, for groundwater recharge, for stream flow generation, for local water use in these different countries or in these different areas? That's something we just need to understand well. And with a lot of appreciation to all the technical and scientific work that has been done so far, I think the next step in this endeavor is probably to really engage in a truly interdisciplinary program. So we need all the atmospheric physicists like Roel and Dr. Eiler and many others, but really engage with hydrologists, really engage with social scientists to fully understand the wider consequences of it, because there's ethical as well as legal issues connected to that, which we need to manage consistently. Yeah.
Which is a beautiful segue into the next topic that I want to put to people. And Kelly, you brought this up earlier, and you referenced AI as an example where regulation and ethics frameworks are trying to catch up to the speed at which it has advanced and developed. Now, I don't want to get you to comment on AI per se, but as an analogy to the speed at which cloud seeding, rain enhancement, and weather mitigation responses have advanced, where are we in terms of an ethical framework, and where do we need to get to?
Well, I think that the ethics problem and the science problem are related. So as we look at these things, you know, we see that both governance and decision making, meaning, you know, whatever we decide about how you make trade-off decisions between how, you know, influencing the system in this way affects the ecosystem, might affect other people or regions. Those questions, you know, you really need information to inform both the decisions you would make and then how you would enforce the boundaries of what happens. And so kind of what we see is like you have this sort of ethical idea that people need to be around the table, but we really have information gaps to fill. If people were to do this at scale and you really wanted to be able to say, well, who is impacted? What are the boundaries of what should be, you know, allowed or pressures on systems and so on. And so they kind of travel together, where these science and observation gaps really need to be filled if we want to be able to manage this stuff ethically. Otherwise, we're, you know, flying blind. People are moving ahead based on their own interests, which is kind of the way it is now. And you can't fault local regions for trying to protect, especially water, you know, in their areas. Like, it's a very fundamental thing. So you can't fault them for just sort of plowing ahead. And so if we want to manage this in a more equitable and ethical way, we're going to need better information and better projections of what's going to happen. So I think those things travel together, and because they travel together, we are in a weak place. We need to start that conversation, then we need to make those investments, and we have to be clear-eyed and say, yes, this can have effects, and also it may have boundaries of what we want to allow. And we got to try to set a framework, both, you know, in a regulatory and diplomatic way, but also in an information and science way.
That's teed this next question up beautifully as well, because I think a lot of the things that you're saying in terms of the governance and the decision making, it's unavoidable that the region that we're in, it's a geopolitical hotbed, especially with what's happening at the moment, but it's very close neighborhood, and you have countries next door to each other who could claim that they're our clouds or that's our body of water. Olof, how do you overcome that aspect? And I'll give you time to think about it, because I'm definitely coming to you for your opinion on that one.
So before I answer that question, I want to just take the take on that original question. And so I think that World Meteorological Organization has been involved in this kind of research for some time. And so it's not like we're starting from scratch. This is the first point. The second point is, I mentioned before that the successes we're talking about is small. So it's not like at the moment there's evidence to believe that there's these leverages that can cause great changes to the natural variability. So the potential for harm is maybe not as big as we think. So that being said, to answer your actual question, I think the best we can do to make sure that we approach these things ethical, bearing in mind that maybe the biggest unethical behavior that we can have is to waste public money, to spend money and throw it to this problem and not really doing anything. To make sure that doesn't happen is to do it responsibly with a science focus and embed it within other services. And I think the region is doing a pretty good job at that. There's this effort to bring in a GCC program. There's good collaboration across borders. I can think of the UAE's long-term collaboration with Oman on this exact problem, where this is the main downwind storms region for them. So I think things are not looking too bad in terms of an ethical approach in the region.
Dr. Mohammed, I'm going to come to you as someone at the Middle East Institute. You'll be keenly aware of the politics of climate diplomacy, which I guess this falls into, and how rain enhancement, call it what you will, is integrated into climate mitigation policies. How tricky is navigating this region and ensuring that collaboration across the Gulf states, across the MENA region, is driving the progress of this sector?
I think collaboration on, we'll call it cloud seeding, and there's a reason I'm broadening the term here momentarily. Across the region, it's gonna, putting aside sort of financial capacity and all that, but just in terms of natural collaboration based on the goal of cloud seeding, is going to depend on the geographies and the atmospheric conditions of those that could partner. And specifically what I mean, you could see a potential natural partnership within the Gulf because of similar geographic atmospheric conditions, high humidity, coastal, flatlands. So when you do the rainfall enhancement, you could potentially target, you could target it in any which way, but one example is to target it on, let's say, at a base minimum. If there's a question on efficacy and all that, but you're boosting precipitation, maybe help boost groundwater resources or shared groundwater aquifers that are, across the region have been historically depleted because of a lack of freshwater resources prior to desalination becoming an option in the region. But if you shift to other parts of the region where you have key or dominant surface river systems that are dependent on high elevation runoff, like the Tigris-Euphrates headwaters in Turkey, like the Nile River Basin, whether you look at the headwaters of the Blue Nile in Ethiopia or the White Nile up in Lake Victoria, those are going to shift to more maybe winter-type cloud seeding, and that goal is a little bit different, and so there's a potential partnership there. So I think the partnership is conditioned on the end use of the cloud seeding effort and local/regional conditions that would be conducive or provide the purpose for a particular type of cloud seeding effort, whether it's rain enhancement, whether it's snowpack augmentation.
It's a very well put answer. Stefan, if you can, we've got 5 seconds to wrap this whole thing up. So no pressure, but taking into consideration everything that's been shared here about the challenges, the ethics, the geopolitics, the technologies, just wrap up for us where we are, where we need to be, and how we can integrate rain enhancement, cloud seeding into more climate mitigation strategies going forwards. It's no
5
small
seconds,
task.
thank you. I think this conversation demonstrated the knowledge that is there, and also the very best intention, not only to improve our understanding, to improve the science and the technologies to be able to do it. On the other hand, I see a lot of openness and willingness for transparency, for sharing, because it was said repeatedly to do cloud seeding in a responsible and ethical good way. We need to be transparent, we need to share, we need to communicate. I think these points were all made. It does need further science, it does need further investments. If I may add, investments across a number of different disciplines to be able to really make the necessary breakthroughs. But I found it very encouraging what Mohammed just said, was kind of knowing the region very well, where there is a lot of water interdependencies among the countries. Euphrates and Tigris comes from Turkey and then flow to other countries, and these interdependencies, this is very fragile. So if we would even with the best intention, would kind of disturb very carefully, naturally equilibrated, sorry for this, systems and bring them into another stage that might cause tension and trouble, and therefore we want to do it with the best science and in a responsible way. So therefore I was very encouraged to hear about the openness and the international collaboration that potentially comes with it.
Which is a nice roundup of one of the overarching messages of this COP, which is being led by science through collaboration. So you did a perfect job. Might have been a bit more than 5 seconds, but perfectly done. Stefan, Kelly, Roloff, Dr. Mohammed, thank you ever so much for your time. Ladies and gents.